Good evening, friends. Welcome to Eastern Academy. As a part of embedded system programming, today we are going to discuss about digital electronics. And today is going to be the session 1. So we are going to have a start about the fundamentals of digital electronics. Normally, we are all very clear about digital electronics. Still, we need to have a good clarity for our embedded system programming. We should have a good clarity about digital electronics. So, you know that everywhere is talking about digital. So we should have a good clarity about digital. Why digital? And what is the fundamentals of digital? That has to be understood. That's a trick. So we may be knowing lot thing about digital in the colleges everywhere, schools and colleges, but still, I would like to put some points what I know and what I've experienced in the industry and what you should know. That's all the trick. So digital is all about very simple. It's nothing. Start with a switch. That's it. If you know how to make a switch on and off, that's about digital. There's nothing more than that. But how it does such a miracle, that is a roadmap for us. For example, in your microprocessors today, okay, people say I have about 100 billion transistors. That means that 100 billion switches, not one or two, 100 billion switches. How are we controlling all of them? Why we need 100 billion switches? What exactly it does? Yes, we are trying to give an answer for all those questions in our digital electronics and the electronics session which is coming next afterwards. So in digital electronics, we use transistor as a switch. That's all. Let us not get into the thing how we are using transistor as a switch. That we will discuss on our electronics session. Okay, what is electronics? What is difference between analog and digital? But here we are discussing about only digital electronics. So let's as usual go to the board. We start with that. Maybe see, I told you, this topic is not as complicated but most useful. See, we always have some different concept. The trick is that if something is easy, we think it's not worth it. No, that's actually a ulta. In this case, digital is very easy. But very much important. Every engineering student from the first semester, they have to practice 2. One is C programming. Other one is digital electronics. The more you become master of digital electronics, the more you understand about today's electronics, everything. Okay, we are not exactly teaching what is your syllabus needs or anything. No, I'm not giving it for any competitive exams or anything. I'm going for the industry. And especially, we are discussing about embedded system programming. So what we need only for that we discuss. We don't discuss too much thing. But this will cover everything. Please understand. This will cover everything. If you understand the digital electronics, you will understand microprocessor architecture and everything. So please give an importance for next 8 sessions. This digital electronics I have about 8 sessions. So what is all about that? It is a simple switch. And we have a supply. And we have a bulb. We start with very simple. Am I right? This is what all about your digital electronics. When I on the switch, the bulb is going to glow. That's all. When I off the switch, then the bulb is going to be off, which everybody knows. Am I right? So why digital? No, that we are not discussing now. That we are discussing in our electronic session. Why digital? Okay. Right now we are going to discuss about digital electronics. This switch have two properties. One is called manual switch. Other one is called automatic switch. There are two types of switches. One is manual, one is automatic. Manual means you use your hand. That's all normally we have it on our house. All the wirings, everything. We control all the bulb, fan, all the electrical devices. We control through manual switch. But the automatic switches, you don't use hand. You use a voltage. You use a voltage to control the switch. If you give 0 volt, switch is off. If you give 5 volt, switch is on. That's it. So we are using a voltage to control. So that's all the automatic switch. Actually, we are using transistor, either BJT or FET. That we will discuss about in our electronic session, how we are going to discuss about this. How we have 3 modes. One is called cutoff, active, and saturation. There are 3 stages. That means that the transistor can be either a variable resistor or a switch. That's it. The active means variable resistor. We call it as analog electronics. Or we call it as amplifier. When it is cutoff and saturation, that is acting as a switch. We call it the digital electronics. Digital electronics. And this is called gate. That's all. So the switch in digital electronics is called gate. Whereas in electrical, we call this as a switch. And in electrical, we connect the switches in 3 types, main 3 types. The first type is we connect a switch serially, or we connect a switch parallelly, or we connect a switch across. Of course, I put a small resistor here. Otherwise, it's if I short it, it will become huge current. So I put a resistor. So there are 3 types. This is first one is called series. Second one is called parallel. And third one is called short. Series circuit, parallel circuit, and short circuit. I can call this as a if, let's say, switch A and B. If A and A, I can write like this. If A and B on, then bulb is on. Am I right? If A and B both are on only, or on. In the other case, if A or B, A or B. See, don't mistake. It's very simple. As it starting itself, I told you, this is very simple. You know that, but it is. It's on. Bulb is on. If A and B is on, one of them is fine. The other one is if A is on, B is off. If A is off, B is on. Understand now? Understand? If A is on, B is off. If B is off, A is on. Because the moment I switch is off, the current is going to through that, the bulb is going to on. So when A is off, B is on. When I on the switch and the entire current goes through this, almost the voltage across this become 0 volt. So the bulb is not going to glow. So that's called when A is on, B is off. There are three combination you could use in electrical. But now we use the same name in electronics, digital electronics. How do we do that? Very simple. Let us draw a small circuit. Think of it. I have a resistor. I have a switch. Very simple. One resistor, one switch. Am I right? Now, this is Y and this is A. I've told that this is a electronic switch. That is transistor as switch. I know that, see, these are all very simple, you would have seen in the college. But still, why I'm discussing this is, I have to start from the scratch. I want to take you there. And at the end, if you go through this way, at the end of it, you will really understand about how the microprocessor works, how your software is controlling a hardware. You should know that. This is what the main portion. When you write a program in software, how it is controlling the hardware, the moment you understand that, you are done. So that's why we are discussing about this. And this will help you to understand all the circuits. Any circuit can be understood by you if you just listen to this. So what we have is, we have a switch. And if A is 0 volt, switch is off. A is 5 volt, switch is on. Am I right? It's very simple. Let us assume A is 0 volt. Now switch is off. What is Y? I apply here 5 volt. Somebody asked yesterday why 5 volt, because I'll tell you, we have to have a start with some reference. But that's why we are using 5 volt always. The industry used a lot of last time for 5 volt. So lot of devices are with 5 volt. That's why we always do with 5 volt. For example, your USB. Your USB is giving 4 wires, 5 volt and 0 volt. Understand? Your power supply, SMPS, use 5 volt. Like that, everywhere it's 5 volt. So that's why we start with 5 volt. Now this is R. Now, when the switch is off, what is the voltage here? Let us do very simple. Am I right? This is V1. This is V1. Since the switch is off, the current flowing through this, I is equal to 0 ampere. Am I right? I is equal to 0 ampere. So V1 is equal to, let's call this as R1. I into R1. I into R1 equal to 0 into R1 is equal to 0 volt. So V1 is 0 volt now. Please understand, V1 is 0 volt now. Am I right? V1 is 0 volt. So Y is equal to this 5 volt, or you call V. Y is equal to V minus V1. That is 5 volt minus 0 volt is equal to 5 volt. So Y is 5 volt now. That is, if I give A as 0 volt, I get Y as a 5 volt. No, across R1 is 0 volt, not 5 volt. I'm not giving across R1. I'm giving 5 volt across the R1 and the switch. Both are connected in series. You understand it? So both are connected in series. Somebody asked, what is the use of 5 volt? I need to have a voltage. If you don't have a voltage, the circuit is not going to function. There should be a voltage. Everything is going to be voltage driven. Electronics is a branch of electrical. So V1 equal to I into R1. So I is 0 ampere because switch is off. So circuit is not closed, no current. Since there is no current, I into R1 is equal to 0 volt. So Y is equal to V minus V1 equal to 5 minus 0 is equal to 5 volt. Do you agree this? If I give A as 0 volt, let us put a table here. I put a table here. A and Y. If A is 0 volt, Y is 5 volt. If you don't agree, let me know right now, please. It's a very simple one. Oh, when there is no current, you don't get the current. Current is, electrons are not flowing, but there'll be a pressure. There'll be a pressure. Let's say in your water tank, in your house, you have a water tank. You have a water tank, assuming that you have a water tank. And there is a pipe here. And you close the pipe, tap. And there's no water. There's no water here. But the pressure here will be the same pressure here. The water will be under pressure. The moment you open it, it will come. So pressure, see, you are getting confused between voltage and current. When there is no current through this, the pressure here will be same as this because there is no flow of electron. That guy is pushing the electron, it comes up to the point, but it cannot flow. It has a pressure here, the same pressure. That's what I proved to you as a mathematically. I mathematically told you this is 0 volt. So don't get confused between current and the water flow and the pressure. Yeah, you can unmute. You can talk. You are always unmute. Anybody can talk anytime. I never mute him.
Sir, good evening, sir.
Yeah.
Sir, my doubt is that we have 2 voltage sources, right? At A and 5 volts, right? So
no, there's only one. No, wait. There is only one. Oh, A is not connected to this. A does not come here. A is only to control the on-off. A does not coming to your. There's no connection between A and this guy at all. This is like a hand. You are using a hand to control. So there is no connection between A and this V. No connection. If A is 0 volt, switch will be on. See that? I don't show the connection at all. Good. There's a very good actually. You asked the question. There is no connection between A and V. Please. A is used to control only the switch. That's all.
Okay, sir. Yeah, sir. My doubt is that why we are using 2 sources. So
okay, A to control.
It is clear.
So this is the main one. This is the main supply. This is the control.
Okay, sir. Got it. Thanks.
This is a control. Okay. That's why it's called automatic. We are controlling the main one doing automatic. Okay. So anybody, sir, this is very good. See that. See, certain doubts has to be cleared now and then. Learn to ask the doubt. If you don't ask the doubts now, you will not be able to ask the doubt in the interview. During the interview, if you ask a doubt, the interview will be very, very happy. Because we are not college. We are industry. The moment you ask that, if you say that I'm asking you a question in the interview, if you tell me, sir, could you repeat me? I don't understand. Done, man. You won the game. The moment you tell me that you don't understand the question, you are actually win the point. Instead, that we will think that a good man. This guy makes sure that first question has to be understood before trying to answer. If you wrongly understand the question and give a wrong answer and tell me after 20 minutes, so I didn't understand the question properly, that is wrong. Please, I'm requesting you, all of you, this is a chance for you to discuss and practice. go away from your college habit of just listening. Otherwise, you can always watch the recorded lectures in YouTube or everywhere. Okay. Whoever asked the questions, I'm quite happy. Please continue that. So you understand that. So if I give 0 voltage at A and why I get 5 volt, there is no connection between this and this. This is only to control. That's it. So now what I do is here is I do another small thing here. See the circuit. What I do here is I have a resistor. I have 2 switches. Then I have a resistor. I have only 1 switch. I have an input. Let me don't connect it. Then you get confused. I put a circle and put the voltage here. If I don't show the connection, then it'll be okay. I call this a and B. I call this output as a Y. Now what we do here is we take this guy and control this switch. There's one small extra addition now. Previously I showed only this, and this is 5 volt and this is 5 volt. And these two are connected to ground. Now see that what is happening. If you understand this is very good. I'm happy. If I give A 0 volt, A 0 volt and B 0 volt, what happens? A is 0 volt, so switch is off. B is 0 volt, switch is off. All right. Since both the switches are off, the current through this is 0 ampere. So the voltage across this is 0 volt. So this 5 volt comes here. The 5 volt comes here. Since this is 5 volt, this switch is on. When the switch is on, we connect the switch directly to what? Ground. So I get here 0 volt. Any doubts here? Please, I've explained that. It's simple. 2 more switches I added. You have any doubt? Please. Anything stop me now. But now what I do here, I give A as 0 volt. I give A as 0 volt and B as 5 volt. Now, since B is 5 volt, this switch is on, but still this is off. So once again, current is 0 ampere, 0 volt across a resistor. So I get 5 volt and 5 volt on, then I get 0 volt. Now, next to what I'm doing is I'm making A as a 5 volt, B as 0 volt. Now A is 5 volt, but B is 0 volt. Now this is off and this is on, but still no use. Still no use because of this. No, this is connected. When the switch is on, this is connected to the ground. So the voltage Y means it is with respect to ground. In any point, the voltage will with respect to ground. So the ground is connected. So there's no potential difference. So it is 0 volt. Because when this is 5 volt, switch is on. When switch is on and it becomes 0, somebody asks, how come it's 0 volt? It should be 5 volt. No, when this is 5 volt, switch is on. When switch is on, this is connected directly. So this 0 volt is coming here because ground is 0 volt.
Sir.
Correct. Tell me now.
Sir, we are getting 5 volts directly at the output, right?
No.
Main 5 volts, main supply.
No. The voltage across this is 5 volt because the entire current is going through this. So 5 minus 5 will become 0 or it is connected to ground. Because this is connected now. Since this is connected, the I is going to, this is R. I is equal to V by R. So this, the current is flowing through this. Understand?
Sir,
That's
how
the reason
5
here.
minus 5, sir?
Huh?
How 5 minus 5, sir? We have only one supply, right? One main supply. Only 5 minus 0.
No, we are applying 5 here, and this 5 volt is making the switch on. Am I right?
Okay. Okay.
This is 5 volt. It is controlling a switch. There is no connection here. The switch is on when I apply 5 volt. Since the switch is on, let us assume now. This is a very simple electrical circuit. Let us say, forget about this. Forget about this now. I redraw it once again. See, I have a resistor. I have a switch. There are two positions. Switch can be on or switch can be on or off. Let us assume that switch is off. When switch is off, the current is 0 ampere. I is equal to 0 ampere. This is 5 volt. The current is 0 ampere. This is R. The voltage across is V1 is equal to I into R1 is equal to 0 volt. So I apply 5 volt and the drop is 0 volt. So what I get here is 5 minus 0 is 5 volt. So when the switch is on, I get 5 volt. Oh, sorry, off. Let us make the switch on. When I make the switch on, what is the current? Current is I is equal to V is equal to IR. I is equal to V by R. So I is equal to 5 volt divided by R. That is what I. Now, what is the drop across this V1? V1 is equal to I into R1. This R1. R. Let's say R. Is equal to I. What is I? 5 by R into R is equal to 5 volt. So across this is 5 volt. Applying 5 volt. 5 minus 5 volt, I get here 0 volt. That is one way. The other way is I connected this directly to ground, the wire. It becomes 0 volt. See, if any point is, what is the voltage is with respect to ground always. With respect to ground. So now since I connected a wire to ground, it becomes 0 volt. That is what I'm doing it here. When I connect here, the two switches. When I connect the two switches, what I do here is, I don't draw 0 volt. When I put the symbol here, that means 0 volt. That is called common point. That's indirectly. So now this output is coming and controlling this guy. That's all. He is not directly connected. When this guy is 0 volt, the switch is off. When this one is 5 volt, switch is on. That's it. Now I have two inputs, A and B. So 0 volt, no current. I is equal to 0 ampere. So this R. So it's equal to 0 volt. Since this is 0 volt, this point becomes 5 volt because 5 minus 0. And this guy is controlling. So this become on. Since this is on, the 0 volt comes here. This is why. This is a very, very simple electrical one, but understand this. If one of the switch is on, that is A is on, B is off, on, then also 0 volt. When A is on, B is off, still no current, 0 volt. But when both are 5 volt, you give both input 5 volt, both are on. When both are on, the entire current is going through this. The ground is coming here. Now this becomes 0 volt. This becomes 5 volt. Since this becomes 5 volt and 0 volt, this becomes 0 volt. And this is off. and this is off, this 5 volt, and the drop here is 0 volt because current is not there. So this become 5 volt. That means that when both the inputs are 5 volt, the output is 5 volt. Understand?
Sir, that output resistor voltage is depends on this switch, right? Below. Switch.
Yes, correct. This switch.
Got it, sir. Got it.
This
Now
switch.
got it.
That's it. That's it. Yeah.
Okay.
There are two. Actually, this is two circuits. If you give here like this, you will not get confusion. It's actually two circuit. Am I right? There are two circuits. Okay. This controls this guy.
Now clear, sir. Thank you.
Okay. So this is one method. And third method is this. What they have done was, they did same thing, but only one small change. They connect the switches in parallel. They connect the switches in parallel. So I have same two inputs. I have same two inputs. Only thing is they connected in parallel. This is A and this is B. Now A is 0 volt and B is 0 volt. When both of them are 0 volt, both are off. When both are off, no current. So I is equal to 0 ampere. So drop is 0 volt. And this become 5 volt. Since this become 5 volt, this become 5 volt. And this is connected. Once this is connected, okay, this becomes 0 volt. Because this 0 comes directly here. So this circuit is separate. So this becomes 0 volt. So 0 volt, that is fine. But when A is 0 volt and B is 5 volt, when B is 5 volt, this is on. When this is on and the current is going through this, and this is connected, so the 0 volt comes here, this becomes 0 volt, and this becomes 5 volt. And this is 0 volt, and the input is 0 volt. The switch is off. Since the switch is off, the current is this one, 0 ampere. So this is 0 volt. You get here 5 volt. When I give A as a 5 volt and B as 0 volt, so what happened? B become off and A become on. But since A is on, the current is going through the thing. So once again, this become 5 volt and 0 volt, and get 5 volt. When both of them are 5 volt, both the switches are on, but no change. Same, the ground is going here. So no change. You get here 5 volt. So there are three possibilities. See here, this is the first possibility. This is the first possibility. 0 volt means 5 volt. 5 volt means 0 volt. That's all I said. A and Y. This is the first possibility. The second possibility is I connected the switches in series. And the third possibility is I connected the switches in parallel. That's all. This is, see, this is the basic. See, you know that you could have done everything. We use the mud or sand to build the bricks. Okay. Then using the bricks, you construct wall. See, this is the way it goes. Am I right? From the mud, you construct bricks. From the bricks, you construct wall. From the wall, you construct rooms. From the rooms, you construct house. Am I right? Now the same thing here. From the sand, that is what silicon. From the sand, we take silicon. From silicon, we build transistor. From transistor, we build this gates. It goes like that. We are going to do that. So that's why we call this is a basic building blocks. These are all. The bricks is a basic building block. Here also same thing. I'll show you two once again now. The thing is that the moment, see why we put this symbol. Tell me now. Why we put the symbol? We know that if I do like this, I start here, I run smooth. Smooth run. But if it is a zigzag, that means that this gives you the resistance. So the symbol tells you that this is a resistance. Am I right? Same way, we make a coil. We have a symbol. So that is the way engineers did. They don't draw the actual picture, they draw a symbol. Like that. Like that. They made a symbol for this. For example, I connect a switch, two switches in series. I connect two switches in series. Sorry. I connected two switches in series. Then I connect another resistor and which goes. All right. Now we connect them and give a voltage here. Done now. Am I right? Now what we do here is, this is the input A and this is the input B and this is output Y. But instead of showing the whole thing, they made us a simple symbol. They made a single symbol like this. A simple, this will be very nice for you. So that's a A input. This is Y output. And there is a 5 volt supply. So like this, I can draw like this. And we call this as an AND gate. I already told you that the automatic switch or transistor as a switch is called gate. I connected the gate in series. I connected the gates in series. But instead of telling I connected gates in series, in electronics, we call this as a AND gate. This is what, so whenever you, and normally we don't show the voltage. Normally we apply a voltage 5 volt and ground. That's why we don't show the voltage. So please understand this. If I draw this symbol, what is inside is this. If I draw the symbol like this, if I draw a symbol like this, and anytime, internally, 1, 2, 3 transistors and 2 resistors. You understand this? This is what they have it internal to the transistor. Sorry, the AND gate. The same way, what I do here is I do a small change, nothing big change. I do a small change. I connect the gates in parallel. I connect the gates in parallel. So this we have seen that A, B. This guy is controlling this switch. This guy is controlling this switch. And this is controlling this switch. Now they change the symbol slightly different. They put the symbol slightly different. they use a symbolics like this. And that's like this. I can draw it here, like here. See, you all know that OR gate, AND gate, everything. I'm trying to say that what is inside. The inside is nothing but two transistors and three transistors and two resistors. There's nothing more than that. They're all physical. They're all physically like this. Because we built like this when I was studying in school. We didn't have the chips. You might be used in the college. 7408 AND gate. 7432 OR gate. 7404 NOT gate. But we didn't have those chips. So we used to build using the transistors, the colleges. We make a small PCB and PCB or PCB like that. We do them. Understand that? Okay. Different functionality. Why you want addition? See, you tell me that why you use addition, why you do subtraction, why do you multiplication, why you have division? You have 4 operations. Am I right? You have 4 operations. The thing is that in the case of AND functionality is when the both our inputs are 5 volt, the output is 5 volt. In OR functionality, if both the inputs are 0 volt only, output is 0 volt. Otherwise, output becomes 5 volt. That's a functionality. Now, using this functionality, we are going to build the full computer. All your supercomputer to all your mobile phone, everything is working only on these 3. Your microprocessor, microcontroller, whether it's Atmel or ARM or whatever it is, all of them are having the same functionalities. Please understand. Nothing more than that. So there are 3 functionalities. How we are going to use them, that I'll tell you next. Now understand that thing. There are series circuit and parallel. Am I right? Now the third one is a quite easy one, which we know already. Very simple one. I have a resistor and I have a switch. That's it. The switch is controlled by an input called A. And the output is Y. Now, what is happening is, the moment I give a 0 volt here, the switch is off. When switch is off, the 5 volt goes here. When I give 5 volt, the switch is on. That time the 0 volt goes here. So they call this as another symbol called, normally they put a circle. This symbol says normally that they call inverter. This round symbol, the circle one. The circle tells you that it is a inverted or not. They always call A means Y. This is actually, if you put a symbol, means A bar. A bar means not of A, please. So this is this 3. So please understand, these 3 could be very, very simple for you. Understand? These 3 could be nothing for you. But let me be honest. Let me be honest. To do the entire embedded system programming, you have to know addition, subtraction, multiplication, division, and or not. That's it. This is called arithmetic function. This is called logical. It's a very, very unfortunate thing. In the schools, we have been taught very well about arithmetic. But very unfortunately, in the school, we have not taught about this. You have to understand from the school stage. Think of it. Think of it. Normally, you say that if everyone comes, then start the bus. Am I right? If all of them, when all of them come, if all come, then start the bus. We use it. This is not addition or subtraction. You don't count how many people. Same way, if anyone comes on the light, the class could be 10 people or 15 people. If one person comes, they will on the bulb light. And we know that when there is a power is on, main power is on the emergency light. When main power is off, on the emergency light. This is called not. We use them at every day. The emergency light is when there's a power is not there, emergency light will glow. If power is 0 volt, emergency will give you 5 volt. If power is 5 volt, emergency will give you 0 volt. We use them. So there are 3 functionalities we use them. Actually, it's happening like this. Understand one thing. This is sand. From sand, we get silicon. From silicon, we build transistor. That we are going to see in analog electronics, in the electronics class. Not now. From the transistor, we built and, or, and not. Am I right? From this and or not, we built addition, subtraction, multiplication, division. Please understand, in the computer, addition, subtraction, multiplication, division are built using these 3 gates. That is a surprise one. That is really a surprise one. Am I right? So you have to understand these 3. But there's one more information I forgot to tell you. I will tell you now. Not forgot, but I did tell you. I can connect any number of switches in series, not only 2. I can switch any number of switches. It doesn't matter. For example, I can connect 1, 2, 3, 4, 5, 6 also. That means I have a 6 input. And I have a resistor. And the output, there is a 1 resistor, 1 switch. Now the trick here is $5 volt. Now this is controlling the switch. Once all of them are 5 volt, then only all are on. Then only this becomes 0 volt. Then this becomes off. You get 5 volt. If one of them is 0 volt, then that switch is off. No current. Since no current, this becomes 5 volt. And this is switch is on. You get here 0 volt. That means what I'm trying to tell you is this. When I put the AND gate can have any number of inputs. Not only 2. I have used the gates with 256 inputs. You can have an AND gate with how many inputs? 256 inputs. Why not 500 inputs? You can have any number of inputs. But if one input is 0 volt, the output is 0 volt. One input is 0 volt. Understand? That's very important. Yeah, I never use the word called no voltage. I'm using 0 voltage. These are all 0 volts. Digital has 0 volt or 5 volt. We will discuss the no voltage at the tri-state. So 0 volt, 5 volt, and no voltage. That we will discuss that time. Don't get confused now. So please understand, never think that your AND gate has only 2 input. You can have a same way. I can put any number of switches in parallel. See, A, B, C, D. That means that I can have a OR gate of 4 inputs. If one of the input is 5 volt, when all are 0 volt, the output is 0 volt. If one of the input is 5 volt, the output is 5 volt. But sometimes we always think that 0 volt and 5 volt. Sometimes people use 0 volt and 3.3 volt or 0 volt and 2.5 volt. And in the mathematics also to use it the voltage. So what we are using convention in digital is 0 volt means 0. 5 volt means 1. Understand? 5 volt means 1. 0 volt means 0 is the one we are using. Understand? Now, the third one is very simple. That has only one input, one output. You will not get A and Y. 0 volt means 5 volt. Sorry, 0 means 1. 1 means 0. So if I think very simple, but this will be very useful. That is, if you use the AND gate, if I have any input, if one input is 0 volt, output is 0 volt. That's it. So 0. Not let us not use voltage. We put 0 means 0. One input. All other can be 1. If 1 is 0, output is 0. Same way, in the OR gate, I have so many inputs. If all are zeros, the output is 0. If one of them is 1, the output is 1. And can be 2, can be any number of 1. The output is 1 only. But if at least one is 1, the output is 1. So the third one is what? Next session you will get an answer for your question. Why and or and not. Why we are using this parallel and series. We will get an answer on next session. So this is A and Y. That's it. So please understand these 3 gates. They are very simple. You could have studied in the college very well, but make sure that these are the building blocks for all your. See, it starts from here. Actually, it starts from transistor and a switch. This is what digital. When I'm going to use as a variable instance or analog, we are not worrying about now. We are in digital. Now, from here, we build 3 gates and or not. Now, from here, we are going to build few logics. This goes like this, finally microprocessor. That means that what I'm trying to tell you is that all the microcontroller, let's say, your microcontroller is built only using the switch. Your switch is built using a transistor. That means that if I say that in my microprocessor, if I have 100 billion transistors, how much? 100 billion. Then I have those many transistors and those many switches. How are you going to control the switches? That is what all your embedded software. That once you understand how your software is controlling the switches, you are the guy wanted by the industry. Then you will not have a doubt about how this embedded system field is become so famous. Am I right? So even though it's very simple, but I took some time to explain to you because We know AND gate, OR gate, and NOT gate, but we don't know what is inside the gates. That's a trick. Okay, that's a very tricky. So they are nothing but, see, I'll go back once again, I'll explain to you a minute. They are nothing but, in electrical, we call them as a series. In digital, in electrical. In digital electronics, we call them as a AND gate. Here we call parallel. Here we call OR gate. Here we call short. Here we call NOT gate. The another beauty is, in this case, we use manual switches. Here we are using automatic switches. Nothing but a transistor. You make on or off using the whatever it is. Forget about whether it is a BJT or FET. It doesn't matter, whatever difference it is. So this is the way we are going to build the building blocks. So please understand, how are you going to build building blocks? The building blocks are all, we use gates, using the switch. So using switch, we build the gates. Now, next session, we're going to see some other application of this. We're going to build another building block. Maybe if we take, this is a brick, this is a wall. You're going to build a wall. You're going to build a wall. What is steady flow for all these topics? I don't understand. I'm not getting your question. There's nothing at all here. It's all like addition. The school learn addition, subtraction, multiplication, division. Here only AND or not. That's it. I don't understand what is the steady flow for all these topics.
Sir, I mean to say that what is the conceptual part that from basic to advanced? What is the?
Oh, no. Individually separate. Individually separate. You should know that when there is a switch controlled by electrical, if you start asking why question, I told you already. If you say that if I put the accelerator, the car is driving. I mean, like, no. I should know that how the accelerator, when I put the accelerator, the car is driving, accelerating. When I apply a brake, the car will stop. No. I should know that. Then you will never get a driver. Understand? You should know that when you are discussing the topic, these are called abstractions. These are called abstractions where a scientist will study about atom, and applied material people or applied physics people will study about material. Then applied engineering. Then there's an engineering guy study about transistors. It goes like this. When the technology guy is trying to understand about atom, you are gone. You will have, the whole world will be studying only atom. So you have to understand what topic you are talking, and that topic you should be able to. Every topic requires some basics. Let us say in this digital electronics, the basics is a switch, and which we know everybody knows how the switch works. And this is called automatic switch. That's it. If you say that unless otherwise I will know about automatic switch, the digital electronics, no, that is not the world work. The world does not work that way. And that is not the way you have to learn. That's the way you start learning in the colleges. When you are coming that thing, then in that case, if you are right, if you say this is the right method, what you have learned the way from bottom to top, then every student coming out of college should be a genius. India should have built about millions of products now. Understand now. We study, first year we study physics. Second year we study physics. Third year we study materials. That is about depletion layer, all the silicon and all the other things. PN junction, then diode, then transistor, then FETs. Okay, then we study regulators, class A, class B, class C amplifiers. That is what. The automatic switch is the one that we are going to discuss in our electronics topic. That is, the transistor have three regions: cutoff, active, and saturation. When you apply 0 volt, this can become cutoff. When you apply 5 volt, this can become saturation. When you apply in between 0 to 5, call active. That we are going to study in our electronic session. But right now, when you are doing digital electronics, you need to make an assumption that there is a switch which is controlled by a voltage. That's it. There are two. That's why we call digital. The 0 volt or 5 volt, 0 or 1. That's it. This methodology is very, very important today. When you join a college company tomorrow, they will do a new project. They will ask you to start from tomorrow. If you have to study everything, all the basics, and come back here, it'll take another 1 month. By the time your manager will say that, hey, better go out of a company, man. That's all. You should know how to start from what do you know. That's why I'm trying to give you the concept. I'll come you later. Then you will understand that thing, why I'm discussing this. I could have taught the electrical first, then I would have taught digital. No, I didn't do that. I didn't do it very specific reason for that. They're all independent topics. Each one is independent topic. Your C language is independent. C programming is independent. Digital electronics is independent. Electrical is independent. Electronics is independent. Everything you should learn as a topic independently. Don't try to connect everything. If you have to learn C language, what should understand? Enough. That is the thing. That is so. Tomorrow, when a company you join, if they say that, hey, learn JavaScript, then you get a project. You say, no. Unless I was why JavaScript has came, who invented and why invented everything, then I will not learn JavaScript. What will happen? Think. Please understand the reality. That's the reason I'm putting the very basics of switch. We all know switch. Only thing here is automatic switch. From that we build the gates. So let's take a small break now.